So basically, when we talk about model, we have a bunch of data right here, right? Okay, and as we mentioned before, we have a lot of features. For example, if we have n features, okay, and we use a big X, okay, to represent all those features. You use those features to describe a data set, okay? And we have a target Y right here. The model means what if I use a big X to describe the relationship between your features and the target, okay? We mentioned before the target Y, okay? It has several different types, okay? It could be numeric, which means it is a number, okay, like your salary, your height, your weight, and some numeric things, okay. The other one is category, right or wrong, yes or no, 1 or 0, black or white, okay. There are some applications, okay, in your problem. When we use the word linear regression, it means the Y is a numeric data. Linear regression assumes that the relation between big X and Y is predefined. Okay, the form looks like Y equals AX plus B. If you have only one variable, x1. However, the general form looks like this: Y equals AX plus 1, BX2, CX3, so on and so forth. Usually we write it in this way. Okay, the variable becomes theta. Okay, so we have a theta 0 plus theta 1 x1, okay, theta 2 x2, and so on and so forth. Usually we write it in this way: theta plus a big theta and xx. The meaning behind those notations is the same. This function, okay, the input is x. We have to describe this function, right? So it has certain parameters. The parameters are theta. So we write the theta right here. All the above things is the same. Sometimes we write a hat right here, which means, okay, the y hat means it is an estimation of y by using the function f. Okay, the input data is big X, and your parameters are theta. And there's a function, okay, you can use big X to estimate the value of y. The value we use right here is y hat. We wish the y hat is close to y, to the actual value, but however, sometimes they're not close. So we have to define certain method, certain function to help us to evaluate the model. As we mentioned before, we use the value MSE, estimate how good the model is. So that's called MSE. Mean means we divide it by n. SE means error, square error. The square is right here, right? The error means the difference between y hat and y. Of course, you can write it in this way, or you can write it in this way. Okay, let's take a look at this one. You can see that this value, basically, it is a shape like this, a concave curve. 它就是凸的哈，凸的。It has a minimum value, so that means the MSE value has minimum value. 最小值，就是什么时候会有最小值呢 ？Okay, it depends on the value of A and B, which is the parameters. You choose different parameters, you get different value of MSE. However, there should be A star and B star, the optimized value, which can make the MS value to be the minimum value, right? So in that time, we find the optimized parameter of this linear regression. This A star and B star is optimized value. Is the best linear regression line for this data set. That's all. I think that is the basic. So what is next? Feature engineering. When we collect those data, okay, we have a lot of features, x1, x2, xn. Usually we have something need to do before we analyze those data, which is called normalization. 这种叫正规化. The first one is min-max scaling, which means you don't use the original x when you analyze your data. You transform this data to another x. Why do we need to do that? Because different features, they have different meanings. For example, weights, heights, your salary, they have different scale. For example, your weight may be between 40 kilogram to maybe 100 kilogram. You have a range 40 to 100. But how about your height? Maybe 120 centimeter to 200. How about the distance? Okay, maybe 1 kilometer to 500 kilometers. We have different values in our data, so they have different scales. If you Google data normalization, you may find this thing. As we mentioned before, when we analyze our data, okay, we use loss function, MSE function, to evaluate our model, right? And we try to find the minimum value of the MSE value, right? So we do partial differentiation to find the loss value, okay? The left-hand side, okay, it is a data set, okay? If you do not do any normalization, when you find a minimum value of your loss function, it may look like this, okay? Because the scale of your data, the curve may look like this, a little unbalanced in different axes. 在不同的轴啊，资料会看起来有点不太平衡，好吗？ When you do the normalization, okay, try to find the minimum value of MSE. When you do the partial differentiation, and your curve, okay, will be look like the right-hand side, 就像右边这个图。So when you do the gradient descent to find the best value of A star and B star, which is your best parameter, okay, it is much easier. And you take less step, 就是你会花比较少的步骤 to find such kind of minimum value of MSE. We will talk about later, okay? You have to remember this. It will be much better when you do such kind of modeling. Before you do that, okay, make sure you do normalization on your data. So one of the way is to the min-max scaling. You simply abstract the minimum value and you divide it by your range, which is defined by your max value and your minimum value. So you get a normalized X. I believe you're familiar with such kind of scaling when you learn some statistic concept. 统计学的时候，这些概念都已经教过了。The other one is z-score. The value, subtract it from your mean value and divided by your standard deviation value. Okay, and you get the z-score. I believe you learned it in when you learn normal distribution. Okay, so that is a z-score. You can do either of it, and that is the gradient descent, right? And that is the MSE value. Okay, for example, if we have two parameters right here, one is A, one is B. As we mentioned before, usually we don't know how to find the optimized value, A star, B star. One of the strategy is to randomly select one value, okay, which is A0, B0, right? So we do partial differentiation. It tells, okay, goes this way, okay? The other one is, okay, go this way. It goes to this way for the next step. Okay, so it's right here. That's A1, B1. And at the purple point, you do partial differentiation again. You find the base direction toward the minimum point. And you so on and so forth, and finally we're very, very close to the A star and B star. Okay, so that is the gradient descent. Okay, we have talked about this figure before. So before we enter next slide, okay, I'd like to talk about the Pandas. It is a Python package, and usually we use this package because it's very easy to understand. You can manipulate your data. Of the data in our class, okay, most of them looks like a table. What is the basic things of a table? If you have only one column, x1, for example, you have a lot of data right here. If your data has only one column, okay, you can use a data structure to store such kind of one column data, which is called series. Okay, it is a data structure. We will not go over everything about Pandas series data structure. You have to make sure you read some document, find some example of how to manipulate Pandas series data structure. Okay, here's an example. You have the data, looks like this. So basically, that is the index, and that is the value. Okay, the index is Ohio, Texas, Oregon, Utah, and value is right at the right hand side. You can describe your data by using Pandas series data structure. Sometimes you might have a missing value. Usually, when we analyze data in Pandas by using Python, NaN means another number, which means nothing right there. So it is a missing value. We will talk about how to deal with missing value in the later class. Okay? Or that is index, that is value, and as we can see that those values are binary value, true or false, yes or no, 1 or 0, which is okay. The other important data structure is data frame. And data frame is a table basically. So sometimes it looks like this right here. Right, that is the index. That's what we call x1, x2, x3, right? And we have 5 data right here, big X, to describe its value. I will skip all of the other things. Just take some time to take a look at those things to make sure you have some basic skill to manipulate the data in the data frame or in the series. Okay, so that's it.